Welcome to today's video. Still on linear algebra. In our previous video, we looked at matrix operations. Okay, so moving on, we'll be looking at the determinants of 2 by 2 matrix, 3 by 3 matrix, and 4 by 4 matrix. Of course, the determinants of higher order of matrices can also be determined, like say 5 by 5 matrix, 6 by 6 matrix, and so on and so forth. But then that is a rather complex one. If you know, beyond a 4 by 4 matrix, you've got a rather complex formation of matrices if you want to go higher than 4 by 4 matrix. So if you want to go higher by 4 by 4 matrix, it is advised that you just basically use programming. Maybe you can use programming language like Python to solve that. So that will be easier using programming language than solving literally. So for a 2 by 2 matrix, the determinants of matrix A, take this for example, is written this way: determinant of A. So top to bottom diagonal, you multiply the elements AD minus bottom top diagonal in this form. So it will be AD minus BC. So that gives you the determinant of matrix A, as A is a 2 by 2 matrix. So moving on from there, a 3 by 3 matrix, the determinant of this 3 by 3 matrix is such that you take the first element in the row, in the first row, so you write it down. So the column where that element is found and the row where that element is found, you can cover it in this way. So you'll be left with a 2 by 2 matrix. So what you do is to look for the determinant of this matrix, this 2 by 2 matrix here, and which is this, as determined earlier. So, and that is for the first element in the row. So you do same for the second element in the row, which is this. However, this time around, you alternate the sign from what it was previously. So initially, we didn't alternate any sign for the first element in the row. So for the second element in the row, you use a negative sign and you write down the element B. So now cover what you've got in the column relative to the element and the row relative to the element B. So what you then have also is what looks like a 2 by 2 matrix. You look for the determinant as well, that is DI minus FG, and that is what you've got here. So, and the third thing you do, you also do some same for the third element in the first row. This time around, you also just alternate the sign, positive, negative. This time around, we'll be dealing with the positive sign. So you write down the third element C, then covering the column and the row relative to this element C, you then will be left with a 2 by 2 matrix form. And when you look for the determinant of that 2 by 2 matrix, that will give you DH minus EG. And so this is the way you compute the determinant of a 3 by 3 matrix easily. So assuming you've got numbers in this as the elements in this 3 by 3 matrix, you see you can easily solve for the determinant of the matrix B. Okay, so then let us move on from here to the 4 by 4 matrix. So in the similar way the 3 by 3 matrix was treated, the first element in the row will be considered first, the second element in the row will be considered next, the third element in the row will then be considered, and the fourth element in the row will finally be considered. So what you do is, when you consider this, you just literally consider that element, and by the time you want to consider the second element, you alternate the sign, and by the time you want to consider the third element, you also alternate the sign from the previous one. So this is a negative, this will be positive, and when you want to treat the fourth element in the row, you also alternate the sign from the previous one. That is, this is positive, this will be negative. So now for the first one, first element in the row, you will have to do away with the row relative to the element and the column relative to the element. So what you are left with will be in the form of a 3 by 3 matrix. So you then look for the determinant of that 3 by 3 matrix using the same procedure earlier discussed. And so that will give you this element multiplied by the determinant of the 3 by 3 matrix. So, and the second thing to do will then be you alternate the sign first, and after alternating the sign, you write the second element in the row, first row. That will be A12, A12, that's minus A12. So when you cover this row, this column, and this row, you'll be left with 3 by 3 matrix. So you also look for the determinant of that. So after that, you then alternate the sign again and write down the third element in the row, and you also ensure that you do away with the row relative to that element and the column relative to that element and the row. So what you are left with, do away with the row relative to the element and the column. So what you are left with will form a 3 by 3 matrix. So you also look for the determinants, and that is represented in this way. So, and after doing that, you then do for the third element in the first row. So don't forget to alternate the sign, very, very important. So from positive to negative, positive, and this would now be negative. So negative of the fourth element in the first row. Then you also cover the column relative to that element and the row relative to that element. So what you've got left will be a 3 by 3 matrix. So you also look for the determinants using the previous method, the previous approach explained, and that will be the determinant of this, and that is how you plug in the values and compute the determinant of a 4 by 4 matrix. Okay, so let's apply what we've just done in looking at some examples. For a 2 by 2 matrix, say matrix C, the rows being 3, 8, and the second row being 4, 6. So to calculate the determinant of this 2 by 2 matrix, what we do is say 3 times 6 minus 4 times 8. So 3 times 6 is 18, 4 times 8, 8 times 4 is 32, so 18 minus 32 gives us minus 14. So let's look for, let's see how to calculate the determinant of a 3 by 3 matrix. Okay, say the matrix is in this form. So the determinant will be, you write down 1, then you say minus 4, you'll be left with this 2 by 2 matrix when you cover the row and the column where the first element in the first row relative to the first element in the first row. So you now have minus 4 multiplied by 9, and this is it, minus 8 times 5, and this is it. So you then alternate the sign, and you have a minus sign here, then you write down 2, then you also do away with the row and column relative to the second element in the first row, and you'll be left with a 2 by 2 matrix that will be 0 times 9 minus 7 times 5, and that is it here. So plus, you do that for the third one as explained earlier, and if done well, the determinant of this 3 by 3 matrix will result in 78. So the third example here will be to find the determinant of a 4 by 4 matrix, this matrix C. So the determinant will be, take the first element in the first row, which is 2, you write that down, and you then cover the elements in the row and column relative to the first element in the first row. So now you'll be left with this 3 by 3 matrix, and it is written here. So you then alternate the sign and write down the minus sign here and write down the second element in the first row, and now doing away with the column relative to the element and the row relative to the element, you'll be left with a 3 by 3 matrix like this. So you do that for the third one and the fourth one as earlier described in the example. Now notice that this here, this isn't 1 but minus 1. So when you alternate the sign and you write minus down, the element here in itself is minus. So you ensure you do not do away with your minus here, because that is tricky. So that will be minus, and at the end of the day you have minus times minus, which will give you plus, a plus. So this example is intentional in order to clear that. All right, so then the determinant of this 3 by 3 matrix is, determined using this previous approach for a 3 by 3 matrix, and that is multiplied out for this second element in the first row. So it is also, the determinant is also computed and multiplied with the second element. And the third one, which is 0, of course anything multiplied by 0 will be 0, and that is why you see 0 here, simply put down. And for this, which is minus times minus, which will give us plus, so we have plus 1, and the determinant of the matrix, the 3 by 3 matrix generated from that particular aspect, is determined here. So if done appropriately, the determinant of this 4 by 4 matrix will result in minus 1 to 5.